Okay, so class today we're going to look at domain and range of a graph. Domain and range. So domain is a set of the independent variables which are the x values. Dependent is your range, and that's your y values. So to figure out which one's dependent or independent, you have to do your depends on sentence. So this would be your dependent, and the other one would be your independent. Okay, so for example, cost and quantity. Does quantity depend on cost? Kind of, but what's really for sure is that the quantity depends on cost. No, cost depends on the quantity that you buy. The more you buy, the more you pay. And so then we can, now that we know which one's dependent and independent, we can then set it up. So the quantity is going to be your independent, and your cost of your total bill will be your dependent variable. So domain and range, to start with, it kind of depends on whether you have discrete data or you have the other type, which is continuous. So continuous data you have to deal with differently. Continuous data you're going to use your inequalities for. But we don't have inequalities right now because we have discrete data. For discrete data, what you got to use is you have to list point values. Okay, if you have discrete data, you actually list the point values. So it's pretty simple. Your domain is all your x values, 0, 1, 2, 3, 4, and you don't repeat anything. Done. And your range, it's quite simple. That's your y values, 1, 2, 3, 4, 5. Don't repeat anything. Now this data set, nothing repeated, but if it did, we'd only write it once. Okay? So discrete data, you list your point values. And when you're graphing it, you don't connect the points, okay? So one thing to make a note of is there's no repeats. So for here, my domain is -2, -1, 0, 1, 2, 3. And we do want to list it in numerical order. That's why I started with my negatives. For my range then, it's going to be the list of this value. Start with my low. Okay, always want to go from your low value all the way up to your high value. And so for my range, I'm going to use -14, -7, -2, 3, 8, 13. So I'm listing them in numerical order. All right. Any questions about these? Continuing on then. So what if I give you as a point? That's okay. You still list your domain. So the x value here would be -7. So that will be one domain. And this here would be -4. So that's my other domain. Now both points have a domain of -4, but I only list it once. Okay, don't repeat and say -4, -4. Here, my y value is -1. Here, my x value rather. Here, x value is 2. Here, my x value is 5. So that is my domain. So then I have to go and I have to do my range. When I do my range, I'm going to start with my low y values down here. These are your negatives. So the low values, and then I just work my way up. So starting with the bottom one would be -5. The next range value would be right there, -2. Next range value right here would be +1. Range value right here would be a 3. Range value right here would be a 6. So I'm just including the point, the values of my x and my y for each point. Is this a function? Well, no. It fails the VLT. So I can say that. Or what else can I say? I can say input -4, and input -4 has 2 outputs. Okay, or what else can I say? Is there another input that has 2 outputs? Yep, which one? +2. Or I can say the input, so I'm specifically saying which one fails it. Input 2 has 2 outputs. So 2 possible values for this x value. Here and here. Here and here. It fails the VLT. Okay. Next one. Determine f at -7. So f at -7, that's my y value. So what there's, x value, x equals -7. So here's -7, and what's the y value right there? It is +3. So x equals -7. So we can say f at -7 equals +3, because that is my y value at this point, -7, 3. Okay, so that is for discrete data points. Now we have continuous data. So for continuous data, you have to use an inequality. And this is where it gets really tricky. So for my domain, my x values start here at 1, and they go continuously right here to 7. Now the graph is actually touching there. So this would be a closed circle. This would be a closed circle because it's touching, and it's all the values in between, because all these x value, all these lines all have x values everywhere along that line. So it's almost like I'm squashing the line on my x-axis, and all the values are covered. They're all shaded in. So for my domain, I always start with what? That's right. Always start with that. Then I check for the equal to part. Since I'm touching, the graph is touching, I have to have the equal to part. My low x value is 1, and my high x value is 7. And then I'm done. Okay, so a low value and then a high value. What about your range? Well, your range is from here all the way to there. And it also includes those points, so you got to shade it in. Okay, and if we squash that graph up against the y-axis, every single point would be covered between them. So it's like the y values all the way along are included. So again, you start like this. Then, since it's touching, you do have the equal to part. And the low value, what's your low value? -3. What's your high value? +3. So y is greater than or equal to -3, and y is less than or equal to 3. Is it a function? No. Why? Because it fails the VLT. Okay, it's a circle right here. It fails the VLT. And in fact, I can move that line anywhere along there and it would fail. Okay, next one. Now it gets tricky. For my x value, x is just constantly opening, and it continues in that pattern because it touches the edge of the grid. So it goes forever in this direction and ever in that direction. So x is between what? X is between nothing. There's nothing containing it. So what we write down, if nothing is containing it, is write down all real values. All real values. And that's because nothing is containing it. But for your y's, it is contained. Here, it's touching right at 5. Okay? The graph touches, and it continues forever down in that direction. It goes forever. So I start like this, and the high value it's touching, and that high value is 5. Guess what? There is nothing stopping it down here, nothing containing it. So you know what I do? I just erase it. And so this is only a special inequality. Y is less than or equal to 5. And that shows my y values are all decreasing, which is what it is. Now, is that a function? That's what the letter F stands for. Is it a function? Okay, so this here would be your domain. This here would be your range. And this F is it a function? And yes, it is a function because it passes the VLT. Okay, so yes, passes the VLT. Awesome. So now we have a different scenario. This one's going to be really tricky here. So let's start with our x's. Start by doing this. Now squash the line. So I bring it up to the x-axis. Notice how it's an open circle? If I want an open circle, I got to show you that. And then it touches everywhere and it keeps going in that direction. So what is my low value? My low value is -3, but it doesn't equal -3. There is no high value. There's nothing stopping it. So I just erase it. And so my domain is x is greater than -3. Okay. What about my range? Well, I start y in the middle. There we go, double signs. And so, according to my y, I would move this over, and it's an open circle there on 3, and it's continuing up constantly. It continues in that fashion. So my low value for my y is -3. My high value does not exist, so I erase it. There's nothing up top blocking it. It continues forever. And so I say y is greater than -3. Is it a function? Yes. Why? Because it passes the VLT, the vertical line test. When you have a graph, you can use your VLT quite exclusively. Okay? Next, any questions? Okay. So that's the nuts and bolts of domain and range. And then what we're going to do is get into interval notation. So again, for interval notation, once again, it is for continuous data. Okay, so it goes forever and ever. Sometimes it has containment points. Continuous data, and so it is instead of the inequalities. Okay, so instead of the inequalities, we would use that. So what we have is we have two types of brackets. So for interval notation, we have square brackets. And with our square brackets, we always have our low value, a comma, and then our high value. What the square brackets indicate is that the points are included. Okay, so square brackets, it includes the value. And so that is like it is a dot. Okay, so when you have a dot, that's when you use your square brackets. When you have rounded brackets like this, you'd still go low, comma, high. And here though, since they're round, it doesn't include the value. So we have round brackets and its values are not included. So it does not include the value. And when do you use that? You use that when you have an open circle. Okay? One other thing that comes up with interval notation, you can also use infinity and negative infinity if it continues forever. Okay? If you use infinity and negative infinity, you must use rounded brackets. Okay? So let's go on here. Domain, range, and is it a function? So the domain, if I move this up to my x and move this down to my x and move that up to my x, I'll have an open circle. I'll have a whole bunch of shading, and then I'll have a closed circle here. So again, you go low, comma, high. So my low number is -3, comma, my high number is +2. Now, I look at my brackets. Because this is a closed circle, the point is included, it must be square. Because this does not include the point, it must be rounded. So you can mix them up, depends on what you need. Okay, the range. So the range is tricky as well now. So now if I squash everything to my y, I touch this point here, this is a point, and here this point shades in the open circle, and so I have all these values in between. So for my range, my low value is -4, my high value is +5, and I touch both of them, so they both should be square brackets. And is it a function? Yes, and that's because it passes the VLT. Okay, there's one output for each input. Okay, next one. I'm just going to go here real quick and finish these ones. So looking at my x, these would all fill in and move up and move down and move down and fill in. But I would have an open circle here, a closed circle here, and then all the values in between would be shaded. And so my low value is -5. My high value is +5. The low value is included because it's a closed dot, so it's a square brackets, closed dot. And the rounded brackets are needed for the high value because it's an open dot. Okay. Now for your range is weird. For this one, your range is going to be specific points. And that is because if I squash this to the y-axis, it'll be a point here. If I squash it, it'll be a point here. If I squash this, it'll be a point here. If I squash this to the y-axis, it'll be a point here. Squash it, it'll be a point here. So this has continuous x values, but discrete y values. Whoa! Combining them. Discrete y values. What do we do with discrete data? Have a look. We just list the data points for discrete data. So for this one now, I have to list my y value data points. So that will be a -4, a -2, a value of 0, a value of 2, and a value of +4. Nowhere does it overlap the vertical line, so yes, it's a function because it passes the VLT. Okay. Now we're going to get a little bit weird. For my x, I start here and I continue forever and ever, nothing stopping it. So my low value is -5, but my high value goes forever. So a number that goes forever is infinity. Not that it's high, it just goes forever. So infinity is not really a number, it's just a concept. The concept is the line does not stop. Infinity does not stop. Weird, but infinity does not stop. Because you can never reach infinity, you must use a bracket that's rounded because we don't actually reach it. But I here have a closed dot, so I have to have a square bracket. Okay. What about my y value? Well, my y value starts at 0, and then if you squash the line, it touches every value and goes forever. So the low value is 0, comma. The high value goes forever. What number do we use for numbers that go forever? Infinity. And we never reach it, so we use a rounded bracket. However, the 0 is a dot, so we reach it. Does this pass the VLT? Yes, it's a function because it passes the VLT. Okay. All right. Next, this one. Here is a line. As long as it is not x equals or y equals, then it is going to be all real values. There's nothing stopping it. Only if it's x equals or y equals do we have to be careful. Otherwise, if it is an oblique line, it is all real values, all real values. Okay. And is it a function? Yes, because it's one output for each input. Okay. What about the next one? Well, this one, we get x equals 11. Graph it. Come on, graph it. Real quick, real quick. Well, here's 11, so I cross at 11. And so this one has a weird domain. Sorry, not the domain. Domain goes forever. So the domain is all real values. Nothing stops it going left or right. But what about up or down? Well, up or down, it only has one value. The one value, whoops, I'm bad here. Oh, Mr. Barker, shameful. Oh, shameful, shameful. Obviously, I did that. X equals 11, not y. So there we go. And so my graph is straight up and down. And I do have values. I have x equals 11. There's a single value for my domain. It's my range that goes forever, up and down, so my range is all real values. My mistake. Is it a function? No, it's not. It fails the VLT. It is a VLT. So it's definitely not a function. Fails the VLT. Okay, so looking at this one, what is my domain? Well, I start at 0 and the ride goes for 80 seconds. So the domain is 0, 80, start, finish, low, high, whatever you want to call it. And they're definite numbers, so they're definitely square brackets. What about my range? Well, I go up to a maximum of 18 and 2. And so I have a low value of 2 and a high value of 18. And it must be square brackets because they're definite. Good thing I start at 2 and not at 0, otherwise the Ferris wheel, that's what it is, would be hitting the ground every time it went around. All right, last one. So this one's a little bit particular. So what I do here is I graph this. So I turn it into y equals mx plus b. I get negative x minus 2. And then I divide by negative 2, so I get positive 1/2 plus 1. So here's plus 1, and my slope is 1/2, so I go up 1, right 2, up 1, right 2, up 1, right 2, down a left, down a left, down a left. However, my domain is between negative 4 and positive 4. 1, 2, 3, 4. So I erase this point. The last one is gone because it's outside my range. And it's a less than sign, so this must be an open dot. Over here for my low, it's an equal to, so it's a closed dot. So this one here is my last point. It's a closed dot, and I have to erase the last one. So my line goes from x is greater than negative 4 and less than 4. There's my line, graphed. Okay, notes are done. Have fun.